Welcome to Carleton's Math Corner. Today we're going to continue our study on parallel and perpendicular lines. Please make sure that you have a notebook, something to write with, as well as your vocabulary packet. Today our target is I can write an equation in slope-intercept form for a line that is perpendicular to a given equation and that passes through a given point. First of all, let's just review that a perpendicular line are two lines that have opposite slopes, meaning they are opposite in sign. So they're positive, negative, so they're opposite of each other that way, but they are also the reciprocal of each other. And they will intersect at a 90-degree angle. So for instance, these two slopes right here, 2 and -1/2, they are complete opposites of each other. See the opposite sign and see that they are both opposite, or the reciprocals of each other. This one is 2/1 and this one's 1/2. The other thing I want to remind you of is slope-intercept form. Remember that is y equals mx plus b. The m stands for the slope, the b is the y-intercept, and our x and our y are basically a coordinate on, or an ordered pair on a coordinate plane. So today let's try and create an equation in slope-intercept form of a line that is perpendicular to these lines. So we're going to start off with number 1, and in order to create a line that is perpendicular, first of all, well, we know that the slopes have to be opposite of each other. So let's start off there. Let's create a line, and I'm just going to choose a different color. Let's create a line, and we're going to start off with just opposite slopes. So if I have a slope of 8, first of all, it's positive 8, so I know that my slope has to be negative. And then I need to take the reciprocal of 8. Well, what fraction would this slope be? What's the rise over the run? Exactly, 8/1. And so if I take the reciprocal, now it would be 1/8. And then I'll keep the x, and I'm going to put plus b because I don't know what the y-intercept is. But I do have a point that our new equation will pass through, and so I'm going to use that in order to create another equation. So I'm going to plug in, just like we did in our last video, to find a parallel line. We're going to plug in the -3, or the -4 and the +3. Remember, our -4 stands for x, it's our x coordinate, and the 3 stands for our y coordinate. So let's start off with 3 equals -1/8 times -4, and then plus b. So now we have 3 equals, and if I multiply -1/8 times -4, and remember this is really 4 over, or -4/1. Okay, so this would be -1/8 times -4/1. And when I simplify that, then it means that I will get down to, well, first of all, a positive, because the negative times negative is positive, and I would have 4/8. But 4/8 is the same as, exactly, 1/2 plus b. So now when you look at this, we have 1/2 plus something is 3 wholes. And I know probably many of you could figure out, okay, well, I'm really good with fractions. I can, figure out what I can add a 1/2 to get to 3 wholes. But let's do it the algebraic way. If I am adding a 1/2 in order to get b by itself, I need to subtract a 1/2. So if I subtract a 1/2 on both sides, then I'm really taking 3 minus a 1/2, and that would get me my b. And so b is 2 and a 1/2. Oops. 2 and a 1/2, or 2.5. So what would my final equation be? Exactly, y equals negative 1/8 x plus 2.5. Nice job. So let's do another one. Okay, so our next one, we have y equals 2x minus 9. So let's start off again. Let's do complete opposite of our slope, and our slope is positive 2. So now that would go to negative, and this would normally be 2 over 1. So I'm going to do a reciprocal, so it's 1 over 2 minus oops, I don't want to put minus 9. Remember, I want to put plus b because I don't know what that is. And then we're going to put 10, 6, because we're going to use that to figure out what the b represents or what our y-intercept is. So just like we did in the last one, let's plug in 6 for y, and then we're going to plug in 10 for x, and plus b. Okay, so we have 6 equals, if I take a negative 1/2 times 10, I have negative 1/2 times 10, so if I take 1/2 of 10, so it'd be negative 5 plus b. So negative 5 plus what is positive 6? Well, remember, do the opposite. So the opposite, the inverse operation of this would be subtraction. If I subtract a negative, remember the double shot, or subtracting a negative turns it into basically just a big positive. So I'm adding 5 on both sides. And if I add 5, so b is 11. So my equation for this one would be y equals negative 1/2 x and I'm sorry, I'm running out of space, so I got to move this over. Negative 1/2 x, and then our b is 11. So there's our answer. Nice job, guys. How about this one? We started off with a fraction as our slope. We have 1/3 x. And so let's do the reciprocal. And actually, I like starting off with a fraction because my reciprocal actually turns it to a whole number, or actually an integer in this case. And so it's actually better to start off with a fraction when you're working with perpendicular lines. So if I start off with 1/3, the reciprocal of that is 3 wholes, and then I need a negative. So it'd be negative 3x plus something, which we're going to figure that out in just a moment. But we have negative 8 and negative 3 that we're going to plug in. Okay, so let's start off. Negative 3 equals negative 3 times negative 8. And let's solve this. So we have negative 3 equals 24 plus b. And inverse again, minus 24, minus 24. And so b is negative 3 minus 24. Exactly. Negative 27 equals b. So our equation would be y equals 1/3 x minus, we could put plus a negative 27, but in algebra you don't usually see plus a negative. You usually have it replaced with a subtraction sign. So let's replace it with minus 27. Awesome. Okay, our last one. What if our equation is not in slope-intercept form? Well, first of all, we need to get it in slope-intercept form in order to figure out what the slope is. And that's the only way we're going to figure out how to create a perpendicular line to it. So if you look at this, we have 10x on one side. How do we move that 10x over? Exactly. Let's subtract. So if I subtract 10x on this side, and I go over and I subtract 10x on this side, now, do you notice I have y equals, and then it would be negative 10x, and I still have my positive 3 that's over there. So now this looks like one of the problems that we've already been working with. And so I can use this equation to create now a new equation that's perpendicular. So let's start off with the slope. Perpendicular to negative 10 would be 1/10, positive 1/10. Yeah, so we're going to be working with a fraction. And so we have, let me put this over. Okay, so we got to plug in some numbers. So we have negative 2 is our y, and we're going to take 1/10 of 30. Well, that worked out nice. Because 1/10 of 30 is just 3. So we have 3 plus something equals negative 2. And remember that in algebra, inverse operation, I know you could probably figure out this answer, but we're just always showing our work steps. We subtract 3 on both sides, and our answer is negative 5. So our equation is y equals negative 10x minus, or not negative 10x, sorry, positive. I was looking at the one that we created originally. But our perpendicular one is 1/10 x. Y equals 1/10 x minus 5. Awesome. Okay, so at this point, I would love for you to try some problems on your own. So here are your ticket problems. So I want you to find the perpendicular lines to these equations using, and they need to pass through those points. Thank you so much for joining me at Carlton's Math Corner, and I look forward to our next video. Have a great day.